Hey, thank you, Rod. So my name is Evans Callis. I'm born and raised here in Fairbanks. You may have, as Rod mentioned, you may have seen me at some past, what did I do? There we go. At some past science outreach events with the Society of Physics students. And today I want to talk a little bit about the HARP facility and just kind of give a basic overview of what the facility is, what we do here, and then talk a little bit about the science and some current research that's going on with HARP. So what is HARP? The HARP is short for the High Frequency Active Auroral Research Program, and it is a facility that's designed to study the ionosphere, which I'm going to talk a little bit more about later. It's located in Gacona, which is about 250 road miles south of Fairbanks. The facility was constructed under the U.S. Air Force and the U.S. Navy. Construction began in the early 90s. The original funding came out of a congressional initiative in 1990. From 1990 to 2014, the facility was run by the Air Force and the Navy. And as the funding for research and development by the Air Force decreased, the scientific community began looking for new people to take on managing the facility. So in 2015, the facility was transferred to UAF. And in 2021, the National Science Foundation awarded a 5-year, $9.3 million grant to HARP to form the Subaraural Geophysical Observatory, or SAGO. And this is a grant that funds most of the research that we do now. Actually, I was going to go back to this for a second. So I did neglect to mention the HARP facility is a type of instrument called an ionospheric heater. And usually people kind of give me a blank look when I say that that's what it is. And that's because there's only 3 of this kind of instrument that are currently active in the world. HARP is one of them, and this is actually still the most powerful and flexible facility of its kind in the world. And the other 2 facilities are the IceCap facility in Norway and the Sura facility in Russia. So what is the ionosphere? So this is a charged layer of the Earth's atmosphere that contains various charged particles. I always call it a sea of charged particles that is primarily formed by the solar wind and interactions between the sun and the Earth's magnetic field. It starts at about 50 miles above the surface of the Earth and stretches to around 400. There's no hard boundaries here. It's all kind of a slow, smooth transition for the most part. But this is essentially the boundary between the lower atmosphere where we live and breathe and work and outer space. There's many satellites that operate in this area, including ones like the space station and stuff as well. We're going to talk a little bit more about that too. So what are some of the impacts of space weather, which is kind of just a term that we use to refer to all of this interaction that's happening here in the ionosphere? Some of the more common things are it can impact satellites and astronauts that are working out in space. Safety for them is obviously of utmost importance, and understanding the effects that space weather can have on them is very critical. It can also affect our communication systems. The ionosphere does overlap with a lot of communication satellites, and interactions in that area can have negative impacts on those. In rare cases, you can actually have interactions in the ionosphere that are strong enough, caused by solar activity, that are strong enough to cause disruptions to power grids here on Earth. Actually, back in 1989, the Canadian province of Quebec lost power for about 9 hours because of a solar storm that took out the whole power grid in that province. It was impacted by the solar wind. We already talked about that. And it's constantly changing. So the ionosphere changes on very short time scales. You have, over the course of a day, it'll change. You have certain layers that only exist in the daytime when the sun's shining on them, things like that. And it does change over the course of the year as well. Some activity is higher during some times of the year and less at other times. And of course, one of the more visible features of the ionosphere is stuff like the aurora, which can be considered a type of air glow. And I wanted to mention a little bit about this because you can see in this picture, or from orbit, you can see a lot of different colors in here. And those different colors can actually tell us a lot about what type of gas is in there, what type of, how much energy is in the particles at certain layers, things like that. So how does HAARP help us to understand space weather? In short, HAARP gives us the ability to conduct controlled experiments that can mimic natural phenomena. So there's phenomena that occur in the upper atmosphere naturally, and HAARP's flagship instrument, the Ionospheric Research Instrument, or IRI, helps us to induce small perturbations and things like that would naturally occur, but maybe they aren't occurring when we want them to occur, when we're actually looking at them. So this basically gives us a way to poke the ionosphere and see what happens. So the Ionospheric Research Instrument is a phased array antenna. So it consists of 180 individual antennas covering 33 acres. Each antenna is 72 feet tall, and the whole system can transmit 3.6 megawatts of power into the ionosphere. Now, as impressive as all that is, the HAARP IRI is only a transmitter, so it doesn't actually give us any data directly. In order to get that data, we need to have passive instruments either on the ground or in orbit. Some of these are at Gakona, some of these are in other places around the state or around the world. And what these instruments do is they basically watch to see what happens when we poke the ionosphere. That can range from camera systems like this one here in the top left to radio receiver systems. And one of the challenges of being a remote Alaskan facility is that you do have to deal with the wildlife. So this is a receiver antenna at the HAARP facility that had a bit of a run-in with a moose. This antenna is supposed to be vertical, and as you can see, it is very clearly not. What happened was the moose walked through the stabilizing wires holding the antenna up and just snapped like 3 of them. And so the whole antenna, I was walking around in the woods trying to find it, and I'm like, I can't see it. Where did it go? Like, I know it's right here, and then I walk a little further and I find it fallen down in the trees. So we're not immune to the wildlife either. So a little bit about research campaigns and current research that we're doing. This is a campaign photo for a current, recently completed campaign that we did with the NASA Jet Propulsion Laboratory. And what this experiment did was we transmitted from HAARP at a near-Earth asteroid, so an asteroid passing relatively close to Earth. And we had 2 facilities that we were working with, the Owens Valley Radio Observatory in California and the University of New Mexico's Long Wavelength Array. And basically, when we transmitted to that asteroid, those 2 facilities would listen for the echo to come back off that asteroid. And scientists at JPL would analyze the data that came back from that echo, and they would use that to try and figure out the composition of the asteroid and other properties, other physical properties about it. The general principle is kind of like ground penetrating radar, except on a much larger scale. And they're still analyzing the data, but the initial results do look promising. We're looking forward to seeing what they get out of it. And so a little bit about our open house and public outreach. So we've conducted a total of 4 open house events since the facility was transferred to UAF in 2016, 2017, 2018, and most recently in 2022. These are some photos from the 2022 event. And across those 4 events, we've had over 1,000 visitors, which has been really great to see. They're a lot of work, but they're a lot of fun to do as well. And we also have active outreach in the amateur radio community. So the amateur radio enthusiasts get very excited about HAARP because it's basically like if they had an unlimited budget and they could make the the coolest ham radio system. That's what HARP is to them. So they always get very excited when we do one of these open houses. So in short, the HARP facility is designed to study the physical and electrical properties of the ionosphere. And even after over 30 years after construction began on the facility, it is still doing cutting edge science now, both in ionospheric physics and in new categories of space weather like the JPL mission. So thank you.